Hope you're there also. So today we're going to talk about something we use every day. Probably spending too much time on it. It's called internet. So we use this every day. Talk about the younger generations. Kind of like natural. This chapter, we have 3 subjects we want to cover for chapter 15. The first subject will be, the first subject will be exactly what is behind internet. Second subject will talk about the currently the very big application of internet is internet generated unbelievable amount of data, so storage. Last topic will be the security. So 3 topics. Started with our first one, the internet. Internet, we are familiar with the applications. So when we talk about internet, most obvious thing coming to our mind is the emails, the web page, social network, those kind of things. Those are applications. That is the last layer, called layer 4. So that's the last layer of internet. If you think about the internet as an onion, so if you look deeper, there are 1, 2, 3 layers underneath the application layer. So we got the application. So most textbook, when we talk about internet, there are 2 approaches. One is bottom up, one is top down. So either way, internet bottom up, top down, 1, 2, 3, 4, 5, 4 layer of 4 layer onion, like 4 layer. So if you look at the innermost layer, it's called layer 1 or physical layer. This physical layer, on a larger scale, we are talking about the backbone of the internet. So if you look at the physical, what exactly is the internet? Is this fiber backbone connecting people through fiber. So in the old days, there are many other technologies. For example, ATM, frame relay. ATM is big because Sprint used to play a big part on ATM technology. That's how to deliver data long distance, ATM. Frame relay is another one. And it turned out the most common is SONET, S-O-N-E-T. SONET is designed in the 80s, if I'm not remember correctly. It's an old technology. It is designed to handle telephone traffic. So SONET was now designed for internet. But as internet became more and more important, more and more common, more and more traffic on SONET, this network designed for telephone, more and more traffic, it became the internet traffic. So, as the internet grew bigger and bigger, it's unbelievable speed of growth in the past 20 years. The SONET, which is has trouble deliver all those large amount of data. It's kind of like a boat designed to handle the older merchandise And then the shipping industry changes. All the merchandise became ship containers. So the old boat can handle containers, but it's not an ideal situation. So now the second technology is designed just for internet, just like the boat designed just carry the container boxes. This technology called OTN, optical network. It is designed just to handle the internet traffic because the internet became the dominant. There's not a lot of traffic on telephone traffic. So everybody using network. And so it is designed for handle the, for example, internet traffic through Ethernet. Ethernet is just like your house, inside your house, when you network computer together. Again, Ethernet is a survivor. There are dozens of other technologies, but Ethernet became the technology today when we think about networking. So Ethernet became the backbone, not backbone, the physical layer of the internet. And this Ethernet traffic is handled by the fiber backbone, specially designed to handle Ethernet. It's called OTN. So NTN right now can handle much higher speed, is 100 gigabits per second and above. So currently majority is 100. And I'm pretty sure that's not enough because the videos, the content became bigger and bigger. So this is a never-ending game. We need bigger and bigger pipes to handle all the traffic. So the current technology, the physical layer of internet is two-word: Ethernet over OTN. That's the internet. Ethernet traffic over OTN. OTN is Ethernet is like the container boxes. The OTN is like specially designed big ocean-going ships, carry only containers, nothing else but containers. So that's the internet physical layer. So physically, it's Ethernet traffic. The Ethernet traffic can be in a smaller scale Ethernet traffic carried by Ethernet switches. But sooner or later, you need the bandwidth, you need the long distance. That is, the Ethernet switch cannot send your data, for example, 200 miles. So that's a fiber OTN came to play, long distance, up to 2,000 kilometers without repeater. So it's amazing technology, 2,000 kilometers. That's kind of from here to New York City directly without anything in between. So that's the physics layer. The second layer on top of the Ethernet is called IP. Well, Ethernet is great. Ethernet traffic is great, but unfortunately, the Ethernet is only the device. There's no way to know where that device is located. So you can carry your cell phone, you can carry your laptop. It has an Ethernet address, but you carry it to travel, and there's no way to know where your computer is located. So obviously, Ethernet traffic is not routable. So you need to find something which is routable. That is where the IP came to play. IP is this manually defined address which is routable. That means as long as you have IP addresses, every routers, the router are the devices to handle IP traffic. So all the routers know perfectly where each IP is located. For example, Missouri Western, they have an IP address. And so as long as the router saw that IP address which belongs to Missouri Western, it will all deliver to Missouri Western. every country has an IP address, a block of IP address. So if you want to send something, for example, to Europe, to for example, Spain, Spain has a assigned block of IP address. So those routers will deliver those data out to Spain. So IP is the second layer. IP make deliver possible. So IP is it's invented in the 80s, 70s, and it started with a small research project. Now became the internet. So IP. IP address is controlled by a consortium called it's an international consortium. So they control who get what IP address, and they control the root servers, name server. Those root name server has a copy of all the IP addresses, which the owner, the location, those kind of things. So they have, for example, 13. If I remember correct, 13. 5 maybe in United States, another 5 maybe in Europe. Asia may have 3. So that's kind of geographically, they have the exact same copy of data. That means who owns which IP addresses, and they're physically where they are located. So IP makes the router, when router see IP address, the router will know where to deliver to. So it will down to Europe, and they see another address, IP address, it will be down to Asia, for example, through the. So this is the second layer. The third layer is the TCP layer. TCP layer is how the internet works a little bit more detail. That is, although you can deliver data using IP addresses, but how big is your data? How do you get the error check? Those kind of things handled by TCP. So what happens is your internet traffic is the first, by the TCP layer, is first break into small pieces. So if you have a image, it's 4 megabytes. Those 4 megabytes will be broken into smaller pieces. For example, 2 kilobytes a piece. And those small pieces will then be sent out through IP channel. And of course, when you send the IP channel, finally it will send it over through the fiber backbone, routed to different locations. So this is TCP. It just makes this is a layer necessary to for the applications to transmit, send and receive large amount of data, error-free. So the TCP layer also has error check mechanism. So if the received data has an error, the TCP will ask for retransmission, or the TCP will wait, for example, for a certain amount of time. If they still didn't receive the packet, it will ask for retransmission. So for TCP guaranteed, whatever computer wants to send from the source arrive in the destination in one piece. That means it will also reassembly because the computer transmitting the data will break into small pieces. And when those small pieces received on the destination computer, they will reassemble into one big file that will be your 4 gigabytes of pictures. So those 4 gigabytes of picture are received in 1,000 or 2,000 smaller pieces. So you get 2,000 or 1,000 of small pieces, and then final assembly. After the final assembly, the last piece will be your applications. So it can be email, can be web server, can be social networking traffic. So that consists of the 4-layer internet traffic. The most top layer will be the application layer. So with that, I will share, give you a demo of the internet traffic, what it looks like, internet traffic. This is so that's captured internet traffic. I'm not sure you will see the same thing as I see it. Let me reshare. Okay, let me share. So this is a program called Wireshark. That's a very popular program. So if you look at here, I captured eight small pieces of internet traffic. It's all started from my computer. The destination computers are outside my house. So there are my computer send an internet packet to this computer. That's IP addresses. Another computer, another. So altogether, I see eight different computers. There's no two computers are the same. So my computer sent out 8 internet traffic, and the protocol. So if you look at let's look at the first one. So if you look at the first one, right here is the complete packet from start to finish. That's a binary. So this is the first data my computer sent out, first data of this internet traffic, and this will be the last data of the internet traffic. Every piece of data has meanings. So if you look at the first group I highlighted, that's the first group. So this first group is called Ethernet traffic. So ended with 0B08. So this is the Ethernet traffic. Second group is IP header, IP headers. So Ethernet IP, that's highlighted is IP. The third is TCP, TCP. So that's the first layer. The layer 1, that's the layer 2. That is layer 3. And very last is the application. So the last will be application. So application data, it turned out has 271 bytes. The complete data is 337. So out of 337 bytes, only 271 is the application data. So that is for the applications. The rest are 3 layers of information. We don't call information, it's called header. So this is a header for layer 1, header for layer 2, and header for layer 3. Let's look at more detail of header of headers of layer 1. So it started with destination computer, that's my router, and followed by another address, that's an Ethernet address. So this packet started with a destination address, Ethernet destination address of my router, because the data, in order for the IP data to arrive at this computer, first it have to be delivered to the router. So this is the router address. That's the brand of my router, Birkin. So that's my router. This is the MAC address, physical address or Ethernet address. So the Ethernet address is 06038E0136750. Every hardware manufactured have a unique Ethernet address. So that is only for that router sitting downstairs. That's the Ethernet address. And that's the source. That's my computer. It's an Apple computer. So that's another Ethernet address. So followed by the types. That's it. It's a IP4 type. There's another type called IP6. There can be any other types, but IP4 is today's internet protocol. IP4, IP6 is there gradually, but we're still using IP4. So that's it. That's the Ethernet layer. A bunch of data tells the source, destination, and the IP type. And after the Ethernet, the second layer will be this layer called Internet layer. So let's look at the Internet. It ended right here. That's if you look at highlight. So ended at 9.9.9b. So if we take a closer look, the first thing is the Internet IP version. The second thing is the length, 20 bytes. So this IP layer has 20 bytes of information. And then it will have the total length, a lot of information. It will have the source computer IP address. That's my computer IP address. And then the destination IP address. This is important. Without destination IP addresses, nobody knows where your package should go. Now, with the destination IP address, every router will check this address and make a decision where to deliver your packet. So that's IP address right there. It helps the router to decide. That's exactly the last byte. So it ended here. That's the last byte of IP addresses. 9B is 155, 9B. And then that's the Internet layer. After Internet layer, there is a TCP layer. So TCP layer ended right here, 47. That's the last byte of TCP layer. Started here, ended here. That's about another 20-some bytes. So if we look closer to the TCP, it started with a source port. Here's something. Every TCP packet has a port address. If it's a web server, the port address will be 80. So the port address differentiate applications. So we will start at port address is 50.317, and port address will be a web server. So looks like this internet traffic is trying to get some kind of web page from a server. The server address is on the internet, so that's the server address destination. So this is a web server, and my computer is trying to get something from the web server address. Server's port address, TCP port address is 80. And then the rest will be the sequence numbers, error check, very important, acknowledge time, because TCP will actually put up a timer. If timer is out, it will think the packet is lost. It will resend or ask for retransmission. Another thing about the TCP, again, error check. So there are the error checksums. When the receiver receives the packet, it will look for errors. How do they know has an error? They will recalculate the checksum and compare with the checksum right here. If they match each other, that means your data is delivered correctly. The last bit of, so that's a TCP layer, that's TCP layer. So TCP layer, third layer. The last piece of the puzzle is the application protocol. In this case, it's HTTP. That's a web request. So the HTTP has 271 bytes. So out of 330 something, 337, you minus 60 something. So there's 60 some overhead. After the 60 overhead, finally we have the application data. In this case, the application data started from here. So that's where the application started. And this is the last bit of data for the application layer. So application layer is basically the rest of the packet will be all application layer data. There's no error check, no errors in the application layer because that is handled by TCP. TCP will take care of the error check. So that is the 4 layers. So if I re-summarize, layer 1, internet traffic, layer 2, layer 3, layer 4. Layer 4 is your application data. Let's look at another packet. Layer 1, layer 2, layer 3, and of course the last layer is layer 4. That's the layer 4. Layer 4 is started from here. It's TCP. The port address is again is 8. So it's a goes to a web server also. So that's 4 layers of internet. 4 layers. Let's look at another one. Layer 1, layer 2, layer 3, and layer 4, last layer. Again, just like all the rest, the last layer ended with the very last bit. That's the last layer. So that's the very last bit. Macintosh Intel. So in this layer, there's a lot of information for the applications. So the application program will take in all the data in this layer. That's the data from start to finish. The application layer will get that data and do whatever you need to do. It can be a message, can be an email, can be a picture, can be this case is a web request, requesting a web page. So when the server at the destination, in this case, that's the computer IP addresses, 67199.248.11. That is the IP addresses of that computer. This is my computer requesting a web page, something like this. Get this information from that server. So hopefully this demo of live captured internet traffic with all 4 layers will help you understand the internet a little bit better. All the internet traffic are assembled like this. So they all look exactly the same. It doesn't matter you are emailing, you are web browsing, you are watching a YouTube video, or whatever. Doesn't matter what you do on internet. Every traffic is assembled with those 4 layers. 4 layers. The layer 1 is called the physical layer. That is the actual physical device will get the network going. The layer 2 is a software layer. It's a pure software layer. The key component is this name server, internet name server. The name server basically tells, for example, this computer, the location, the owner of this destination computer. Can be google.com, for example, can be whatever web server. All right, that is our first topic, internet. Internet. The second topic is the storage. Storage is hugely important on internet because we are dealing with almost unlimited amount of data. The data getting bigger and bigger every day. For example, your data package in Google may be bigger than all the hard drives inside your house. So you may have hundreds, if not thousands, of gigabytes of data Google hold about you. So just one person, you are not that even famous, yeah, because you're just average guy. They hold in hundreds of gigabytes or even thousands of gigabytes of information. So everything you ever did on that Google platform, if you have a Google cell phone, a huge amount of data is being taken from you. You kind of acknowledge that. That is because when you're using your cell phone, you just click accept, accept, accept. You don't even read what you actually accepted. Basically, like it's like everything. They know everything about you. So they need a lot of storage, obviously. The old days, the storage are called DAS. That means direct connection a couple of feet away. So you have a hard drive, you have an interface, you plug in, and you have your storage. That is old days called DAS. And gradually we evolve. It became a network storage device. Now, the network storage device means the storage may be not just a few feet away, just local, like on your computer. My storage is right inside this machine. The network storage means the storage is on your local area network. For example, in my basement, I have a hard drive. It's a network storage. So every computer can share this network storage. Network storage has an IP address, just like all the computer does. So when I'm accessing that IP address, that is a computer which just provides storage. So network storage is one way up from the DAS. The most recent, or the largest, and the most complicated, the most secure, is called SAN. SAN is a dedicated storage behind the servers. So SAN means is what you dealt with when you dealt with Google's, Amazon's. Their server is not directly accessible by the end user for safety reasons, because they don't want their storage device to be exposed to be potentially by a hacker. So if you look at the network storage, the author has a pretty good picture of not network, storage area network, SAN. If you look at SAN, it's kind of like this, the picture SAN. So this is a SAN network. It's beyond the internet, beyond local area network. The local area network computer right here will never able to access those hard drives. The only way for those computers to access the hard drive is through the servers and then access the storage area network for safety. So this storage is inside this area is extremely safe. away from the hacking, whatever activity going on here. Nobody can access those drives except through a server, indirectly. So all the data is accessed through SAN, indirectly through a server. So this is a special network, usually made of fiber for speed. So that is the ultimate storage for a large company, big corporations. Oh, that's our second topic. The last topic will be a topic everybody cares about when you are on the internet, which is international, billions of people using this network. You are exposed out there. So how about security? To talk about security, there are so many subjects about security. So it can be one separate class for a couple semesters. So the internet security. The first security is this IP security called a firewall. Firewall just check the IP addresses. So this is usually can be enabled by your router. So your router will enable a firewall. That means if when you set it up, if the network traffic came from certain IP addresses, it's kind of like a blacklist of IP addresses. It will be blocked. So that's first security. The second type of security is this big topic of encryption and decryption. That's a hugely important topic, encryption and decryption. And that's a very complicated subject. But it has a very friendly interface, user interface. That is, this is a typical encryption process. You have your data. Encryption algorithm will using a key to encrypt your data, so that your data sent out to the internet. And when the data arrive at destination, there is another key to decrypt your data, and the original message will again the receiver get your original message. So anyone can hijack your data over here, and they have no idea what that data is because they don't have the keys. So usually the keys have a public key and a private key. So you use the private key to encrypt, and the receiver will use your public key to decrypt. That's make it even more secure because your private key, nobody ever knows your private key. And if they want to hack your private key, it will take an average hacker maybe millions of years to get the right key. So it's extremely safe. The hacker have no resources to find your private key. The public key is distributed freely. For example, you put it at the end of your email message, that this is my public key, and everybody knows your public key. So public key are supposed to be public, so everybody know. So that is encryption, decryption. The last topic we'll talk about the VPN. This semester, I don't see anybody doing a VPN project, but the VPN is a huge technology. One way to do VPN is security. For example, if I'm outside my house, I can securely connect it to a VPN server in my house. If I'm away from work, I can securely tunnel or connect to the employee, for example, Missouri Western. That way, all the traffic between Missouri Western, between the company you work and between your home is encrypted, both sides. So people can hijack your traffic in the middle, but they have no idea what your traffic is or are, or what kind of data they are, unless they are NSAs, National Security Agency. They probably have method to, but I don't know. Anyway, VPN will be extremely secure because you will have this secured tunnel, if you put it that way, between a remote computer and a server. The server, you can build a VPN server inside your house. When you have VPN server inside your house, then you have a secured way to connect to your house. Of course, the VPN works using the keys also. That's assuming nobody knows the key. So when you set up a VPN server, the VPN server will provide you with a key. You should never let anybody else know that key, because whoever knows that key can VPN into your house. That will make your house obviously broke into your house, almost like. So that key should be handled with extreme care. For example, you do not want to email your keys to yourself. Again, why do you want to email your keys to yourself? Because it's a different. So you never want to do this, because when you email the keys to yourself, your key will be part of the email, and everybody can read that email, will get your key. Also, all the emails are archived, so the email you send out will never disappear. So that key will be basically out there. So people with some people can get that key. Anyway, that's the VPN, virtual private network. So that will be all three topics we want to cover for today related to the internet. This subject is huge. There's a huge amount of information. Every little bit of a topic, there is a huge amount of information. So it's something we just get a very shallow introduction on the surface. So the three topics are the 4 layers of internet traffic. That 4-layer internet traffic, once it's assembled, it's kind of like a container box sent by the fiber backbones. In this case, would be OTN. The older technology is called SONET. The even older are called ATM and frame relay. It doesn't matter what kind of boat. Those are the 4 different type of boat to carry your Ethernet traffic. It doesn't matter what kind of boat you're using. It all get the job done. The second will be, once you got the boat, once you get the traffic delivered through the boat, what kind of application you use? A big application is storage. More importantly, the SANs, which is all the large data centers. The last one is security. You want to know a little bit about security and how the security works, and hopefully secure your own house internet traffic. All right, that will be all I want to talk about chapter 15. One thing I want to mention again is this program called Wireshark. Wireshark, this will be the live captures of all the internet traffic. When you capture internet traffic, for example, on my computer, you will get a ton of data. So what I did is I use filters. So I just pick a small percentage of the internet traffic I captured. In this case, 8 pieces. So with the right filter, you can actually watch all the internet traffic inside your house. So that is technically potentially possible. You can capture all the traffic, or maybe impossible because more and more difficult. So this Wireshark currently I'm using, I don't know. Maybe I'm not an expert on Wireshark. So my understanding is today, 20 years ago, I can capture all the traffic. For example, my kid is using a computer. I can capture the traffic to and from his computer. Today, it's becoming almost impossible. Maybe there is a way to do it, but it's getting more and more difficult to capture other. So all the traffic I captured is to and from my computer. If I want to capture traffic on another computer inside my house, for example, I have 2 Raspberry Pis sitting in front of me. If I want to capture the traffic goes in and out of that Raspberry Pi, it's the same Wi-Fi traffic, but it's becoming more and more difficult. So that's another thing. You might need some other creative ways if you want to capture traffic of another computer. All right, that's all I have for you guys for today. And